All right. So for those of you who missed class the other day or simply want to review this before your next test, this is a supply and demand graph with taxes and a free response problem that's similar to what you could see on the AP test in the spring or on your upcoming Unit 2 test. So this was a free response question from a previous AP test, and what we have here is a supply and demand graph that illustrates the market for calculators. So there we go. Let's just dive in. The first part of the question, we've got, again, supply and demand, supply with tax, but first calculate the producer surplus before the tax. So before the tax, the price is $5, and I should change my color so that we can see this a little bit better. The price was $5. The producer surplus is that area above the supply curve, below the equilibrium price, and so we have a pretty nice large producer surplus. To calculate it, we simply need to figure out the area of a triangle, which is 1/2 base times height. Well, our base, this distance here, is 90, and our height from $5 down to $2 is 3. So that's $3. If you can't do that math in your head, 90 times 3 is 270. Divided by 2 is going to be 135. So there's your answer. If you can't do the math in your head, you can, of course, use your little 4-function calculator. Second one, there's a per unit tax. We show it. This is a $2 tax on that, and we have to figure out first the tax revenue and then the after price tax and so on. Well, if you were a seller who used to sell for $5, naturally you would try to pass that tax on, that extra $2, that difference there, onto your customers. But if you tried to charge $7 up here, there'd be a surplus in the market. And so market forces would naturally drive you to the new equilibrium price and quantity, which you can see here is $6 with a quantity of 60. So what's the tax revenue? Well, at $6, you're getting $2 per calculator that you sell. So it's really the area of this rectangle here. But you could also just think of it as the new quantity, 60 times the $2 tax. And you'd see we have a tax revenue of 120, which is the area of that rectangle. The next thing is, what is the after price tax that sellers now keep? Well, they're selling it for $6, but $2 is going to the government. So 6 minus 2 equals, hey, they're keeping $4. Now, if you're confused, they are saying the price, so they're really looking for $4. But if you're like, hey, I'm not sure whether they're talking about price or the revenue that they're keeping, you could say sellers are keeping $4 per calculator times 60 calculators, so their revenue is a total of $240. The answer we're looking for is 4, but if you said that extra part, if you're just confused, you'll be sure to get it correct. The last thing then is the producer surplus. Well, our new price that our sellers are getting is this $4. So again, we're just taking the area of this triangle, but it's a little bit smaller now. Now we still take the area of a triangle as 1/2, but our base is now only 60, and the height of that triangle, the difference between 4 and 2, is only $2. And we see that the new producer surplus is just $60, so much smaller. The last one is probably the hardest part, and what is calculating the part C, not the last part. The last one's actually easy, but the next part that's a little harder is the elasticity, and there's really 2 ways that you can solve this. I'm going to first do it kind of the default way, I think, which is look at the percent change in quantity over the percent change in price. And as I went from $5 to $6, my quantity demanded went down from 90 down to 60. So I lost 33%. If you don't remember how to calculate a percent, go review that. But it's new minus old over old. So 60 minus 90 is negative 30, over 90 is negative 1/3 or negative 33%. My price change was from $5 to $6. That's a 20% price increase. And I'd see that this is 1.6. It's actually negative, but again, demand elasticities are always negative, so sometimes we ignore the negative. Oftentimes we just ignore that negative. If I see an E of 1.6 that's greater than 1, I would say this is, therefore, it's elastic. Now, that's a fairly quick, easy way, but if you don't like calculating percents, the other way to do it is the total revenue test. So at $5, total revenue is 5 times, we're selling 90 of them, so 5 times 90 is 450. Sorry, my brain stopped for a second there. At $6, total revenue is going to equal 6 times 60 is only $360. Therefore, we could say it's elastic, but let's think about that for a second, why I know that. If it was inelastic, then increasing my price, I should increase my revenue because I'm not going to lose much quantity. That's the definition of inelastic. So by raising my price 20%, and if I only lost a small percentage of my customers, my total revenue would logically go up as I raise my price. If it was unit elastic, then it should really have no effect on my revenue because raising my price, I'm going to lose an equal percentage of my customers, and my net revenue is just going to be a wash. It's going to come out the same. In this case, I raised my price and my revenue went down, which must be because I lost more customers than I was able to raise my price. And so that would define it as elastic. So this would be the other way to answer that question. Lastly, assuming no externalities, which is something we haven't gone into yet because that's in a later unit, what would be the net effect? Well, there's two ways you could say this. First of all, we incurred a deadweight loss. So we would say that we're less efficient. Or you could say that the producer and consumer surpluses are smaller than they used to be. So either way of saying it, it's less efficient because increased deadweight loss, or you could say less efficient because a decrease in consumer and producer surpluses. So that's it. That was me rapidly going through it. Hopefully that helps as you look back at this problem. As always, let me know if you've got any questions.